I have developed an open source custom web search agent that aims to beat or match the performance of Perplexity. My open source custom web search agent can run locally with Llama, can work with almost any open source Hugging Face model, or can run with the OpenAI models available to you via the API. This is the third and final video in a series of videos where I've been putting my custom web search agent to the test using a variety of local and open source models. In this video, I'll continue that testing by running parallel tests in a series of questions that I've crafted. And after that, I'll be ranking the models on a matrix that I've designed. In the last video, I tested the Llama 3 70 billion model. You can see the results of all the previous tests I've done on screen right now. As you can see, Perplexity is still ahead, but the Llama 3 70 billion model did give it a run for its money, almost matching the performance of Perplexity with my custom web search agent. I'll be running my web search agent on a variety of tests, including the OpenAI models, Mistral models, Phi 3, and also Llama 3 models. So stay tuned if you want to see the results of that testing. If you enjoy this content, give the video a thumbs up. Remember to subscribe to the channel for more large language model and AI insights. The GitHub repo containing the code for the custom agent is available to you in the link in the description for this video. So if you wish, you may check that out. All right, let's get into the testing. I want to touch on the questions I'll be using to test this custom web search agent briefly. So there are 7 questions and each increase in difficulty as you move up the screen. So at the bottom of the screen, the easiest question, and at the top of the screen, the most difficult questions. The more difficult questions tend to have multi-hop aspects to them, which means that the web search agent will have to find various pieces of information before they can actually answer the question. I'll get into more detail about that when we're running through a demo. Because I have a large number of models to test today, I have run some of the tests ahead of time in the interest of time. This is with the exception of GPT-4o, which I'll be running a live test to show you a demo of the web search agent. Remember, the GitHub repo for the web search agent is available in the description to this video. So if you want to test the web search agent for yourself with the questions I have or your own questions, you're free to do so. The model we'll be testing first is GPT 3.5 Turbo. So let's get started on that. If you're running the custom web search agent for yourself, you should know that everything is centered around this agent.py script. And at the bottom of this agent.py script, you have the choice of working with either Llama, RunPod, where you host your own inference server, or with OpenAI. So the last test I conducted was the GPT 3.5 Turbo, and that's why I have that uncommented. If you wanted to work with your own RunPod inference server, you would uncomment the parameters for RunPod. If you wanted to work with Llama, you'd uncomment the parameters for Llama. Remember to comment out the parameters that you are not using. So if you're not using OpenAI, comment OpenAI and use Llama if you want to use Llama instead of OpenAI. I have a video showing you how to set up your own inference server on RunPod, so I'll link that in the description to this video. I also have a walkthrough of this script and going into the details of the Python code here using the Llama local installation. So check that out too. I'll link that in the description to this video. All right, let's talk through the results of the test. Okay, so I'm going to talk you through the results of the test I ran using the GPT 3.5 Turbo model. When you're initiating the agent, what you want to run is Python agent.py run, and you run that in a PowerShell. I'm using the Anaconda PowerShell today. You're then prompted to enter your query, and the query in this case is when did the capital of Nigeria change? Forgive the spelling mistake, the agent should be able to handle that. So the first step here, for those of you that aren't familiar with this agent, is it will be the custom web search agent has a planning agent. The planning agent's job is to come up with a search query that is suitable to be used in Google search to be able to answer this question. So in this case, the planning agent has come up with a search query, and the query is when did Nigeria change its capital from Lagos to Abuja? That sounds sensible. And then we have some other agents whose job is to pass the search query and actually feed it into our search tool, which is used to return a search engine results page. So you can see here, we've passed that search query. When did Nigeria change its capital from Lagos to Abuja? You can see it's lifted directly from what the planning agent has said. And then we have the search engine query returning this search engine results page. So bear in mind for the next few examples, I'm not returning the search engine results page. I've suppressed this in just to make things a bit neater. But just for the first example, for those of you that aren't familiar, I'll show you what this search engine results page looks like once it's printed to the screen. It won't be printed to the screen for the other examples. So we return the search engine results page, and we have all of these links returned. And then we have another agent within our custom web search agent that its job is to look at the search engine results page and choose the best link to answer the question. So the best page is identified as the wiki page for Abuja. And let's just make sure that that is actually one of those returned. And it is. You can see here, it's the English wiki page for Abuja. So we've returned that. And then the next thing is to scrape that URL. Again, for the next few examples, you're not going to see the scraped text returned to the screen because I've suppressed that for brevity. So we scraped the URL and we've returned some context. And you can see it's quite long context here. And then we have an integration agent. And the job of the integration agent is to take that context and try to answer the question. If there's enough information within the context to answer the question, the integration agent will provide a response a direct response to the initial question, which in this case is when did Lagos change when did Nigeria change its capital? If there isn't enough information, the integration agent will actually provide feedback to the planning agent and to help it adjust its search to fill in the missing information. So in this case, the integration agent says, based on the information provided in the research, the capital of Nigeria changed from Lagos to Abuja on December 12, 1991. This change was part of the strategic plan to centralize the government and enhance administrative efficiency. So I'm not going to go into everything here, but we have got an answer. And we've got a source here, which is the wiki source. We have the information here in the wiki source. I'm just going to search 1991. Here we go. So declared capital, 1991. And we can see Abuja. So it looks like it's pulled from the wiki source, at least. The information seems to be consistent. And then we pass it to a quality assurance agent. So what that quality assurance agent does is it analyzes the response from the integration agent and has some set criteria that it marks it against to make sure that it passes the quality assessment. If it doesn't pass the quality assessment, this gets filtered back. There's an iteration process where it goes back to the planning agent with some feedback from the quality assurance process. And that feedback also goes to the integration agent as well. So it can actually change its approach to make sure that it passes the quality assurance process. But in this case, the quality assurance process has been passed. So we've marked that as true. And the final response is just regurgitation of the response, the last response given by the integration agent. So in this case, we got the answer right. December 12th, 1991 was when the capital of Nigeria changed from Lagos to Abuja. So that's the correct answer. So that's a pass for GPT 3.5 Turbo in this instance. Let's quickly step through the results of the other questions. So the next question we wanted to ask on the test is, what is the current population of New York City? So we passed through the planning agent again, and the planning agent has come up with some sensible queries about the current population of New York City. Then we've actually gone through and found some sources. And what we've found here is we failed to retrieve the information from some of those sources. So that's what all of this failed to retrieve stuff is. And the agent's set up in such a way that if you can't scrape data or you scrape data from a website and it's garbled, it will try a different page. And the retry mechanism isn't perfect. Sometimes it does get stuck on the same page, but eventually it will get to a different page, and that will iterate through until it does get to a page where information can be scraped from. So we've landed on this nyc.gov site, and the integration agent has come up with a response. So it says, based on the information provided by the Department of City Planning, DCP, of New York City, the current population estimates for New York City can be found in the New York City Population Estimate Report, Vintage 2023. This report includes latest population estimates. So what we have here, without reading everything, is the agent has actually not answered the question. It's told us where to find the information, but it hasn't answered the question. And you can see the quality assurance agent has actually marked the response as true. That meets all criteria requirements, which I wouldn't say is true, because it isn't comprehensive. It's not comprehensive, and it is what, although relevant, it's not comprehensive because it doesn't actually answer the question. And that's just down to the way the model GPT 3.5 Turbo is interpreting those criteria. So I would say this is a fail on question 2. I'd say that it didn't actually answer the question, and it could have, because all it needed to do was iterate back if the quality assurance process had failed it. And by the way, this quality assessment is run by the same GPT 3.5 Turbo model. So that's a failure in the reasoning capability of that model, because the model should be able to see that the question wasn't answered, and then it would go back and find a different web page where we could get an estimate. So I put that down as a fail. let's move on to the next question. The next question is, who won the Premier League 2023-2024 season? Again, we've got the planning agent coming up with some sensible search queries. And then we have the visited site, which is the Wikipedia site. And the integration agent says the winner of the 2023-2024 season was Manchester City, which is correct. And by the way, that's not going to be in the training data because the Premier League 2023-2024 season ended about 3 weeks ago at the time of recording this video. So it's really recent at the time of recording this video. So it won't be in the training data. That's the correct answer. It was Manchester City that won. And we can just double check on the Wikipedia page that that is indeed correct. So 2023-2024, and you see here the champions were Manchester City. So that is correct, and won their 4th consecutive title. And I think we've even mentioned that here. They secured their 8th Premier League title, which is correct, and their 10th English title. That was mentioned on the Wikipedia page. And first men's team to win 4 consecutive titles. Great. So that's a pass for question 3. Moving on to question 4. So question 4 is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Planning agent, again, has come up with what I'd say aren't that sensible. Well, they are sensible queries. So planning agent has suggested to search for Tyson Fury versus Usyk boxing match result. Search query is Tyson Fury versus Usyk boxing match result. And then we've got a Wikipedia article with Tyson Fury. So the integration agent says, based on the research provided, the birthplace of the loser of the boxing match between Tyson Fury and Usyk cannot be determined. Okay, so you can't determine the birthplace of the loser of the boxing match between Tyson Fury and Usyk. The information about Usyk's birthplace is missing from the research. To find out Usyk's birthplace, further research is required. That's a failing in reasoning because the actual loser of the boxing match between Tyson Fury and Usyk was Tyson Fury. So the agent should have, this being a multi-hop question, the agent should have first been able to identify who was the loser between Tyson Fury and Usyk. And once they found out who the loser was, that's the first hop. The second hop is, okay, find out the birthplace of the loser. So it's jumped straight to finding out the birthplace of Usyk, which is a fail in reasoning. And then the quality assurance agent has actually passed this as meeting the quality assurance standards. And I would say, first of all, it's not relevant. And it's not comprehensive. And also, there are no citations. So the fact that it's already identified there are no citations, but still passed it, means that there's a failure in reasoning here in terms of the GPT 3.5 turbo model being able to act as the quality assessment agent. So that has actually come back as a fail for that question. Moving on to question 5. Question 5 is, find me the cheapest flights to Barcelona from London for one adult leaving next month. So this is sensible. Cheapest flights, London to Barcelona next month. So that seems like a good start from the planning agent. And then we have our search query, cheapest flights, London to Barcelona next month, one adult. Seems sensible. And then you can see we tried several websites. So we tried Kayak, failed to retrieve. And we also tried Skyscanner. And it looks like we've actually pulled that information from Skyscanner. And we returned a comprehensive response from the integration agent based on the information we pulled from Skyscanner. There is also a source here. So what are we saying? The cheapest flights, London to Barcelona, is approximately £26. This is estimates data collected from various airlines and travel providers. The lowest price flights for London to Barcelona are typically in September. So I don't know how true this information is. That might well be hallucinated. But let's have a look at the cheapest flight. Let's see if we can get that from the source. So it says London to Barcelona is approximately £26. Bear in mind, these do change often, and I did run this test a while back. So let's just hope that the flights haven't updated in that time. So do we have a flight from £26? Yes, we do. So I'm going to mark that down as a pass. I know there's a bunch of other information here that we probably should verify, but just strictly speaking, we have actually managed to find the cheapest flight. And when I say the cheapest flight, the criteria here is just returning a cheap flight. I know it's not entirely possible to return the cheapest flight because you'd have to go to every website to pick that up, or you'd have to have it connected directly to the API of the flights. We don't have that, but returning a cheap flight and also a source for that flight is good enough. So that is a pass for that question. And we'll move on to the next one. And you can see the quality assurance agent has passed that correctly as well. So we'll move on to the next question. So the next question is a multi-hop question that requires answers to several questions in order to answer it. So the question was actually derived from a research paper that used single hop questions and composed them to form multi-hop questions. So if it does sound a bit weird grammatically, that is why. I'll link the research paper in the description to this video. So the question is, how many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So you need to know Aruba's continent, which is South America. You need to know Cristiano Ronaldo's country, which is Portugal. You need to know the colonial holding governed by the colonial holding in South America governed by Portugal, which is supposed to be Brazil. And then it's how many Germans lived in Brazil. So those are all the hops. Let's see how the agent handles this. So the agent straight away hasn't broken out all of those different hops, which is what you'd expect it to be able to do if it was going to answer this question. Instead, it's kind of got all of these multi-hop questions that it's going to search for, which I think will have no chance of answering by searching for in Google. And you can see this because we visited a Wikipedia site, and the search query was population of Germans in Aruba's colonial holding governed by Cristiano Ronaldo's country. So straight away, you know that's not going to be a useful search term to answer this question. We have returned some information from Wikipedia, and we have returned a response. And again, you can see the failure in the logic here because there is no citation returned. You can see that here in the quality assurance dictionary. Yet the quality assurance agent has passed it. So GPT 3.5 Turbo isn't working too well as a quality assurance agent, and we've returned a final response. And, you know, I'm not going to read all of this, but it's not the correct answer, essentially, because we started off on the wrong foot. And actually, there's multiple hops that we need to answer to respond to this question. What's going to be interesting is for you to see how the more powerful models actually approach these multi-hop questions. And you'll see that they actually break them down into sub-questions that make sense in order to get to the final answer. So that is a fail for question 6. Let's move on to the final question, which is question 7. And that is, this is another multi-hop question, by the way. What is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? So, as you might have guessed, if it couldn't get the previous multi-hop question, it doesn't get this one either. And again, we have some failed quality assurance here. Because, well, actually, it took a different approach. It actually took a shortcut approach. I won't skip past that. So what it did is it said the planning agent, which is find the team that finished second in the 2023-2024 Premier League season. That is sensible. Determine the city where this team played its last match. So that's good. That's also a good way to break out this question. Identify the largest city north of this location, and then check the current weather forecast. So that's how I would expect it to approach this multi-hop question. So what have we done? Find a team that finished second in the 2023-2024 Premier League season. Great. So we have found out that it was Arsenal that finished second, which is correct. And again, remember, this information is not in the model weights. So this has had to have pulled from some context. So it's unlikely that it's going to have hallucinated this. And we have our sources here. Then it goes on to hallucinate some complete, like this is not factual. So it says the largest city north of London is Leeds. So we didn't even identify where they played their match. Oh, we did. The last match of Arsenal in 2023-2024 season was played in London. That's correct. It was played, I believe, at Arsenal's home ground. Then it says the largest city north of London is Leeds. Incorrect. The largest city north of London in the UK is Birmingham. So that's just incorrect. That's a hallucination. It's not true that the largest city north of London is Leeds. Unfortunately, the specific current weather forecast for Leeds is not provided in the research. So in this case, what you'd expect is for the quality assurance agent to not pass this, so that to be marked as false. And then the integration agent should have come with feedback to the planning agent to say, look, we know that let's imagine it got it right this time, that the largest city north of London is Birmingham. Can you go back and find the weather forecast for Birmingham today? And then the planning agent would have come up with a search query, and we would have been able to pull that information and return a comprehensive response. But that's not the case. The quality assurance agent always passes this stuff. regardless of whether it meets the criteria or not. And that is definitely a fail in the model's reasoning. So for the final question, GPT 3.5 Turbo does fail. All right, so stay with me to tally up the results of GPT 3.5 Turbo, and we can see where it lands on that matrix compared to Perplexity and the Llama 3 models that I tested. We have our questions, and we know that the first question was a pass. So that's 1 point awarded to GPT 3.5 Turbo. The next question, we failed. We didn't get the answer. We didn't get an answer for population. So that's 0 points. The next question, we got the correct answer, which was Manchester City. That's 3 points. That's a total of 4 so far. The next question, we failed. We didn't get to the answer of the birthplace, which is Wythenshawe, Manchester. The next question, we got right. So we managed to return some flights from London to Barcelona, and they were the cheapest flights available on that website. So that's 5 points. And then the final 2 questions, we failed. So I think in total, our tally is 1 plus 3, which is 4, plus 5, which is 9 points. So 9 points leaves us between D and C tier. So that is underperforming Llama 370 billion Instruct, and that was obviously my own VLLM RunPod hosted version of the model at full precision. I think full precision for Llama is technically the 16-bit model, and also underperforms Perplexity, but performs better than the Llama 3 8 billion Instruct, which was the quantized version. That's the local version used with Llama. No surprises there, perhaps. All right, let's move on to testing one of the larger models. Initially, I wanted to test the Mixtral 8x22 model. And in trying to set up my own inference server for that model, I found that it was just going to be too expensive. It would require something like 8 A100s, 80 gigabytes each to actually set up that inference server. So I can't test that model, unfortunately. But what I have found is a fine-tuned version of Llama 3. So this is the Llama 3 TenyxChat 70 billion model. And the authors of this model have claimed to have improved the performance on the base Llama 3 70 billion model on the specific benchmark MT bench. And I think this is a benchmark that measures a bunch of things to understand how well a model is going to perform as an assistant. So I thought this might be a good model to actually go and test. And I have done the testing on that already. So next, I'm going to talk you through some of the results of that testing. And I do think it's interesting. So stay tuned for that. I'll link the model card for this model in the description to this video. So you are free to check that out if you want. I'll also link the paper for the MT bench in the description to this video too. So feel free to check those out if you're curious about what TenyxChat have done with this Llama 3 70 billion model. All right. Let's look at the results of the Llama 3 70 billion model, the TenyxChat variation. Right, on screen, what you should see are the results of the testing I've done on the Llama 3 TenyxChat fine-tune. So I'm not going to go into detail about the easier questions because I think by now you should know how this works, especially if you watch the other 2 videos. But essentially, we had correct answers for the first question, which was, when did the capital of Nigeria change? We had a correct answer delivered there with an appropriate citation. And you can see the quality assurance agent has done its thing and passed that answer. And then for the next question, this is one that actually the previous model, GPT 3.5 Turbo, wasn't able to get. So we were able to get an answer to this using the model from Llama 3. Sorry, the TenyxChat variation. So the answer we got here, and to remind you, the question is, what is the current population of New York City? We have the planning agent breaking that out in a sensible way. So, it's identified the search current population of New York City, and we've put that in as a search. And you can see it tried a number of websites before getting to an appropriate site. And then we return an answer here. So based on the research provided, the current population of New York City is estimated to be roughly 8.4 million. All right, so apparently this is taken from the US Census conducted in 2020. So look, granted, it's not the current population, but this thing is just using Google search and it's just picking out from what's available to it in the search results. So I'm going to open this up. And I'm going to do a search on that population. So what did we say it was? We said it was 8.4. So let's have a see if we can find that anywhere in here. So one of the issues here is that I am not able to actually see all of the information on this page. So we have a current population of New York City quoted to us as 8.4 million according to the 2020 census. But honestly, I'm not able to tell whether that's coming from this source, which is what the source that was provided, or whether that's something that has been hallucinated by the model. And I can see here that census is mentioned, but it's behind this wall, and you need to be a site member to be able to see all of this information. I'm not ready to create an account on this website to see the full population information. I'm in two minds about whether to give the model a benefit of the doubt in this case, because it seems as if it has pulled from the source. But yeah, I can't confirm that. So maybe I'll give half points for this answer, for getting to this answer. So we'll move on to the next question. And the next question was, who won the Premier League 2023-2024 season? And this was pretty easy. It was able to get to the Premier League winner in no time. So you can see only 2 steps. So it says, based on the research provided, the winner of the Premier League 2023-2024 season is Manchester City. And, you know, things about winning their 4th consecutive title. That's pulled from a wiki source. And just to show you that that's a real source. And we know that that information is coming from that source. Or we can assume it is because it matches the information within the source itself. And we know that's information is not in the training data for the model. So that's another pass for the Llama 3 TenyxChat version. Let's move on to the next question. So the next question is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Now, this is a question that the last model, GPT 3.5 Turbo, the last model that I tested, struggled with. It wasn't actually able to break out the different hops of the question. So if you recall, this is a multi-hop question because, you know, first of all, we need to know the loser of the boxing match between Tyson Fury and Usyk, and then we need to find out the birthplace of that loser. So it says the most important search question is Tyson Fury versus Usyk. And what I'm going to do is I'm going to actually bring on the GPT 3.5 Turbo approach to this. So what I've done here is I brought up the GPT 3.5 Turbo response to this same question, so we can compare like for like how the different agents handle it. So on the left-hand side here, we have the Llama 3 fine-tune. So this is a 70 billion model. And the right side, we have GPT 3.5 Turbo. So if you notice, with the planning agent straight away, they both identify that Tyson Fury versus Usyk boxing match result is the most important thing. And then the search query, they both identify Tyson Fury versus Usyk boxing match result. Tyson Fury versus Usyk boxing match result. Now, when we go on to the next bit, the integration agent for GPT 3.5 Turbo says, based on the research provided, the birthplace of the loser of the boxing match between Tyson Fury and Usyk cannot be determined. Whereas the integration agent here says, based on the research provided, the loser of the boxing match between Tyson Fury and Usyk is Tyson Fury. So it's actually found out the answer to the question we're looking for. So that shows some increased reasoning capacity compared to the GPT 3.5 Turbo model, because this didn't understand, or it sort of understood in the first steps that we need to find out the loser of the boxing match, but it just jumped straight to determining the birthplace of the loser, and it didn't specify who was the loser. In fact, the information about Usyk's birthplace is missing. So Usyk was the winner, so it's just jumped straight to assuming that Usyk was the loser. Whereas this one has managed to identify that Tyson Fury is the loser. And then it says, according to the research, Alexander Usyk won the match by split decision. Then it comes up with some information about Tyson Fury. So it says the birthplace of Tyson Fury is Manchester, England, United Kingdom. Now, this might well be in the training data for the model. And here is where the challenge comes in, because if I enter this Wikipedia article, it's probably about the fight itself. So we have, here we go, hometown, Manchester, England. So I think what's happened is it's picked up hometown as birthplace. Let's just have a look. Manchester. Yeah, so Manchester's mentioned once. So it's picked up hometown as Manchester. And from this article, it's basically killed 2 birds with 1 stone, because what it's done is it's picked up that Tyson Fury was the loser. Let's see. There's only winner mentioned once here. So Tyson Fury billed as a Ring of Fire. Tyson Fury. It was scheduled. So Usyk won by split decision. So it's picked up that Tyson Fury here was the loser. And it's also picked up from the context that Tyson Fury was, his hometown is Manchester, England. So it's kind of killed two birds with one stone, which is fine. And I think technically we can count that as a pass. But I think what's more interesting here is you can see the reasoning difference between the Llama 3 70 billion model, the fine-tuned version here that we have, that's the 10x version, versus the GPT 3.5 Turbo, where it kind of got lost in the reasoning here. And notice remember what I was saying about GPT 3.5 Turbo and the issues we have with the quality assessment. It's just passing everything as true, whereas this seems to be more accurate quality assessment. And we'll see that as we go on further with some of these questions. All right, let's look at some of the later questions. So find me the cheapest flights to Barcelona for one adult leaving next month. So the planning agent again comes up with some sensible queries, and we've identified some cheap flights, and we are using Skyscanner. And as of last time, we've got some more information here, and I'm not going to go into all of the details of this. You can play around with this yourself when you get a chance, but essentially prices starting from £26 is what we're looking at. And if I head to Skyscanner, hopefully it hasn't changed, the pricing hasn't updated, but you can see prices starting from £26. So technically it's not departing as next month, but I'm still going to give it as a pass because I think that's down to the nuances of the Google search itself. So that has worked. Let's move on to the next question, which is a multi-hop question. So this question is, how many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So if you heard the last time we tested this with GPT 3.5 Turbo, you'll know it's a multi-hop question. And notice here the planning agent has actually successfully broken out those hops. So what country is Cristiano Ronaldo's country of origin? Identified as the most important search. What continent is Aruba located in? What is the colonial holding in Aruba's continent governed by Portugal? So this made an assumption, and it's stated that it's made an assumption, which is good. And then how many Germans live in that colonial holding found in search 3? So that seems like a solid plan from the planning agent to me. Now we go through, and the integration agent has picked up. So it's based on the research provided. I must clarify that the original query is based on incorrect assumption. Cristiano's country of origin is Portugal, and Aruba is an island located in the Caribbean Sea, which is not the same continent as Portugal. So there's a misunderstanding here. The integration agent has really misunderstood the question, and it's kind of guided us away from the original question. And you can see this because what we want to do is identify, quite rightly, as what the planning agent has picked up, we want to identify what continent Aruba is located in, since we already know Cristiano's country of origin. And, okay, we've searched about Cristiano Ronaldo. It should have picked up Portugal, but the integration agent should understand that, okay, the next thing we need to know is what continent Aruba is located in. Whereas it's kind of taken it to be Aruba is an island located in the Caribbean Sea, yes, which is not the same continent as Portugal. So no one's asking if it's the same continent as Portugal. The question is, how many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? Right. So I think maybe the grammar of this thing is poor and it's tripping up the models. That could be it, but it's worded like that to be tricky. And I suspect a model with a decent reasoning capability should be able to pick that up. Not to say that Llama 3 hasn't got a decent reasoning capability, but I'm surprised that it's not able to tease that out. All right, so that's a fail on that question. So that is our first fail, actually. And then we will go down to the final question. So the final question is, and by the way, just before I move on to the final question, the response quality assessment was a pass, and the reason it gave was, says the response is well-structured, coherent, and comprehensive. It correctly identifies the incorrect assumptions in the query and provides clear explanations and evidence to support its claims. The response also provides relevant citations to credible sources, making it a high-quality response. So the reason for passing it does sound reasonable, assuming that there are some incorrect, well, we know that there aren't, the initial query wasn't incorrect. but it's assuming that, it's going on that basis that the integration agent was right, and it's picked that up, and the quality assessment has then gone on from that point. So actually, in some ways, that's a good thing in some ways. But yeah, I think we could have done better in teasing out the answer to that question. And then the final question is our final multi-hop question. And it is, what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? So we've got a most important question. So we've got 2023-2024 Premier League standings. And then we bring out our search query, which is great. And then the integration agent says, based on the research provided, I can answer some parts of the query, but not all. That's expected. It's multi-hop. From the research, I can determine that the team that finished second in the 2023-2024 Premier League season is Arsenal, and that I know that to be correct. And it's provided a source here. I'm not going to go into the source because there's quite a lot to talk through. So notice here, the response quality assessment is false. So what reason does it give? So the response is relevant and coherent, but it is not comprehensive, as it does not provide the weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match. The response acknowledges the limitations of the research and requests additional information to provide a comprehensive answer. Great. So that's what we want. So this shows the quality assessment agent is working well compared to when we used it with GPT 3.5 Turbo. That's fantastic. And then we move on to the planning agent. So based on the feedback, oh, by the way, I think I didn't tell you what the feedback is. So specifically, I would like to request the following. So the integration agent actually provides feedback. The city where Arsenal played its last match in 2023-2024 Premier League season. That's right. That's what we want. So based on the query and the feedback, I'll generate the following search queries to answer the question. So the most important search, Arsenal's last match in 2023-2024 Premier League season. So we have put that as a search query, and we found some information here. And what I noticed is, I'm not going to read through all of this, but essentially what happens is the integration agent goes back and forth saying that it can't answer the question because from the information it's provided, it's not able to ascertain where Arsenal played its last match. And this actually happens for several cycles. You'll see it. So as I continue to scroll down, and you can see 2023-2024 Premier League season final standings, and we're just trying to get to that last match. So I need more information. Specifically, I need to know the city where Arsenal played its last match and the largest city north of that city, right? So we're stuck on those last two hops. And you can see this goes back and forth. And you can see the planning agents taking that feedback and trying to find where Arsenal played its last match. This happens for quite a few iterations, actually. It goes back and forth on this until, I'm skipping through these, until we get down to the bottom here. So finally, we have a search from the integration agent, the city where Arsenal played its last match in the 2023-2024 Premier League season. So it says, based on the research, I can answer some parts of the query, but not all. From the research, I can determine that the team that finished second in the Premier League is Arsenal. Yep, and we have a source. Additionally, I can determine that Arsenal played its last match against Manchester City at the Emirates Stadium. So I don't think that's correct. I don't think they played their last match against Manchester City. That is not correct. Arsenal actually played its last match against Everton. And I don't know whether this is a guess or a hallucination. Sorry, same thing. I don't know whether this is a hallucination or whether this is in the context, but it says that Arsenal played its last match at the Emirates Stadium, which is correct. And if I pull this up on PremierLeague.com match, let's see where that leads us to. I see. So I think what's happened is it's actually picked up an old website. So this is from October 2023. So that's not the last match, actually. That's match week 8. So that's not the last match of the Premier League season. So it's picked this up. And Arsenal did play at the Emirates, and it was against Manchester City. But that wasn't the last match of the season. So it's not actually a hallucination. It's actually more that the agent has picked up the wrong source of information. And that's great, because that's why it's good to be able to identify the source. And that's why having the source of the information there is really important. So we go on to actually run out of iterations. And that's because I have a set number of iterations for this custom agent. And if it times out, it doesn't complete it. So what we have here is the quality assessment agent has marked the response meets the requirements as false. So this doesn't actually count as a response because we haven't completely answered the question. And that's because, we're not able to, we don't have enough iterations to answer what the largest city of London, or north of London is, although that could well be in the training data. But this agent is designed so that all the information is pulled from sources. It's not supposed to use its training data. So that's interesting. I think that's interesting. It came close. I think it was on its way to answering that question. I think if it had maybe 2 or 3 more iterations, it would have probably been able to get a weather forecast for us. And it's interesting that, the source that it pulled was really the issue. It wasn't so much about the model not, I think first of all, it's probably hard for some of those sources to identify where Arsenal was playing, whether they were playing home or away, because sometimes it doesn't actually explicitly mention that in the sources. However, it did eventually find the source, and that source was an old fixture, basically, and it's taken that old fixture. And I guess there's nothing in that would tell it that that was the last match. I guess if we read match week 8, if that was pulled into the context, it should have been able to figure that out, but it wasn't able to figure it out anyway. I thought that was really interesting. And it's, there you go. The open source model actually outperformed the proprietary GPT 3.5 Turbo. I guess we shouldn't be surprised because GPT 3.5 Turbo was released quite a while back. However, I know that they've been updating the training data and they have been making improvements to the model. So perhaps we would have expected 3.5 Turbo to do a little bit better, but the Llama 3 TenyxChat model, so this is a 70 billion parameter model, seems to have done pretty well on this task. So next, I'm going to tally up all of the points. The last question was obviously a fail, by the way, guys. I'm going to tally up all of the points, and I will then put the Llama 3 TenyxChat on the matrix so you can see how it performs versus the other models I've already assessed. Okay, time to tally up the results. So we know for the first question, the model passed that, so we assign 1 point. The second question, we are assigning half of the available points because ultimately I couldn't see the source of the information from where we were putting that population answer because it was behind some kind of paywall or something like that. So we'll assign half a point there. So that's 2 points in total. The third question we got right. So that is 5 points out of a possible 6 so far. The fourth question we got right. That's a further 4 points. So we're up to 9 out of a possible 10 points. The fifth question, again, we got right. So that's 14 points. And then the last 2 questions we know that we didn't get right. So that's not bad, actually. And, I think this question, the second question, on another run of the model, we probably would have gotten to an answer that from a source that wasn't necessarily behind a paywall. So I think even penalizing the model for that question is harsh, but to the strictest level, I can't give it 2 points because I couldn't identify the source of the data behind that paywall. So let's have a look at the model and where it stands on the matrix. So on the matrix, we have the Llama 3 TenyxChat, 70 billion. I've aligned it with Perplexity because it's a total of 14 points, although I believe Perplexity actually got 15 points. On a good day, I think that it would have matched Perplexity. And I did notice, you guys can go back and watch the Llama 3 70B Instruct video that I did. But I did notice that this model played a lot better as an agent than the Llama 3 70 billion Instruct. And that's the version, obviously, of Llama 3 70 billion that was fine-tuned by Meta. This uses the Llama 3 70 billion base, and they've done their own fine-tuning on it. That's interesting. So we have our first model. We have our first model that matches or gets near to the performance of Perplexity. Next up, I want to test some of the models from Microsoft that are generating a lot of hype right now. So the Phi 3 medium, I'll start off with that and see how well we can do on this matrix. So stay tuned if you want to see how well the Phi 3 medium model does on the series of tests. Right. I have just finished testing the Phi 3 medium 128K context instruct model from Microsoft. You can see here. And I've also included the prompt formatting here. So the stop tokens and all the things you need to ensure that the model returns some coherent responses. as I mentioned before, when I'm testing these open source models, I'm hosting them on my own VLLM inference server that is hosted on rented GPUs on RunPod. I have a video detailing exactly how to do that. So check that out. It will be linked in the description for this video. Let's explore the results of the 5.3 median model. So this was very interesting. I'm going to zoom past some of the more obvious responses. So the capital of Nigeria, as you know, when did the capital of Nigeria change? That's question one. And we managed to get a coherent response from that. And it's, again, returning this Wikipedia article about Abuja. And we have 12th of December, 1991, which of course is the correct answer. So we'll move on from there. Let me zoom in a bit. The next question is, what is the current population of New York City? Now, this was interesting because we got some sensible responses from the planning agent, but initially actually errored out. And I'm not sure what was the cause of this error, actually. So I ran it again. You can see the error here. I'm not sure what caused this. I ran it again. And, you can see here where I ran the query, what is the current population of New York City? We got some sensible responses from the planning agent again. So the search that we should be looking for is current population of New York City 2024. That makes sense. And it shows good awareness that it's picked up the time, date and time, which of course is included in the prompt. Current population of New York City was our search. And we went through a bunch of pages here. We went through to this HTTPS worldpopulationreview.com and we're getting garbled text. So that means that when we were scraping this page, it was returning text that we classify as garbled. It wasn't able to interpret what was in that text. The issue I had, and this was a recurring theme with 5.3, is where other models were able to pick up that this is returning garbled text and then go and try a different page. 5.3 kept retrying the same page. And I found this to be a worse issue with 5.3 than I have with some of the other models I've tested. So what should happen based on the prompt scheme that I've set up is that if a page returns garbled text, it should move on and try a new page. It doesn't always work, but most models will skip on and manage to pull from a different page. And what I found with 5.3 is that it wasn't able to do this at all. So you can see we've got a reputation of pages here. It keeps visiting the same page, this world population page. And you can see under the visited sites, we've only visited this one page. We should have visited numerous pages here because we should be trying different ones. I have to put that down to a failure in the model because other models have been able to, even with my prompting being suboptimal, other models have been able to actually pick up a different page from that search engine results page when we've returned garbled text. And you can see it continues to do this. And the integration agent rightly says, look, we can't answer this. It says, I'm able to provide the current population of New York City because we keep visiting this page. And there's an awareness that, we failed to retrieve it due to garbled text because it understands there's an error that's passed to the integration agent. So we go back and forth like this and it gets stuck in this loop. And eventually it does get round to trying the census page. So we get into trying this census page eventually. So it has managed to correct itself and pull a different page. You can see this here, visited sites. We've got the census page. So it says, based on the research provided, I'm unable to provide the current population of New York City in 2024. The research source, and we got the census page, did not yield the desired results. To provide a comprehensive response, I will need an up-to-date and accurate data on the population of New York City in 2024. I recommend refining the plan to include reliable source that can provide the current population of New York City in 2024. So it is passing back some feedback to the planning agent. And the planning agent really, I mean, put it this way, I don't think that's the most helpful feedback, but the planning agent really isn't even adapting its search. We're still going for the same thing. And you would hope that what would happen is instead of picking up the census data again, we pick up a different website that might have the information we need. So we have gone and picked up the census again, where, arguably it shouldn't have picked up the census. It should have picked up a different source, but we've gone back to the census. And obviously the integration agent says the same thing because we don't have that information in the census. And then we go on and we continue this approach. We continue going back into the census. And you can see now we visited the census for the third time. And this is, again, showing you that the model is actually breaking down here because it should have selected a different page from the search engine results page. And we keep going. And again, you can see we've picked up the census again. And this will keep going until we actually reach a point where we run out of iterations. So this goes on for a while. Here we go. So there we go. And you can see the response quality assessment is false because we do not provide a comprehensive response. It doesn't provide the population of New York City. It just tells us that the data isn't available. And that's because we keep entering the same data source. So that's kind of the difficulty I found with the 5.3 model, whereas some of the other larger models have been able to detect when a page doesn't have the information and then change the page, which is prompted to do. The 5.3 model struggles with that, and that's been a recurring theme. So that's a fail on the New York City population question. Let's move on to the Premier League question. So this one, I believe we got right, and it was quite an easy one. So you can see there who won the Premier League 2023-2024 season. We go straight into breaking out some sensible search queries. We have a sensible one, Premier League 2023-2024 winner. We find a page, and let's check this page out. Let's make sure it's sensible. So I'm just going to bring the page on screen. Bear with me, but I'd like to show you the response first. So the response says, based on the research provided, Man City is in pole position to be crowned champions of the Premier League 2023-2024 season. So you might already see there's something wrong with that because the season's over. The season is over at the time of recording this video. So it's picked up an old page. It's not picked up the latest page to tell you that Man City actually won the Premier League. So this is talking as if we haven't finished the season yet. And that's because it's selected as the page, this page. So yeah, it said Man City has 91 points. So it has pulled the information from the right page. However, it's not answering the question actually, because what it should have been able to do is identify from the search engine results page that we want the winners of the Premier League 2023-2024 season. So it should know the season's over, and it should understand that this doesn't answer the question because the season is over, and that's implied in the question. So it hasn't actually done that exploration, and the response quality assurance has marked this as true. So we have an answer here that is incorrect because it should know that the winner is Manchester City. The season is over. It's happened at the time of recording this video, although it happened recently. It's not in the training data, but it should have been in the Google search. So that's another fail for question 3. Let's move on to question 4. So question 4 is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? We get a sensible response here from the planning agent. The Tyson Fury boxing match approach. Opponent, Tyson Fury versus Usyk boxing match result. And it says the most important search is Tyson Fury versus Usyk's boxing match result. I agree with that. Obviously, we returned a source here from ESPN. So it says, based on the research provided, the loser of the boxing match between Tyson Fury and Alexander Usyk was Tyson Fury. That is correct. And that won't be in the training data either, by the way, because that boxing match happened recently at the time of recording this video. Let's go into the training data. Let's go into the source data. So there we go. Usyk defeats Fury to become undisputed champion. Seems sensible enough to me. And then we have Tyson Fury was born in Wythenshawe, Manchester, England. Now, I doubt that's come from that source, but let's just have a look. It might have done. Let's have a look. Let's see if Manchester is mentioned anywhere. So Manchester is not mentioned anywhere in this article. What about Wythenshawe? Nope. So that's not mentioned anywhere in this article as well. So that is something that was in the model weights, but it is the correct answer. So funny enough, we will give a pass to question 4. So far we passed on question 1, question 2, question 3 were fails, and question 4 was a pass. The next question is around the cheap flights. So it says, find me the cheapest flights to Barcelona from London for one adult leaving next month. So this was where the serial offender was in terms of finding a page to actually scrape some data from. It wasn't able to move off this kayak page for a number of iterations. And you can see that here. So I'm not going to go through all of them, but you can see all the error statements here. And obviously the integration agent is just saying that, it wasn't able to return any information. And this is something that continues all the way until the end of the iteration for the agent. And you can see this here. It's constantly trying to access the kayak page. And then, okay, it does try some other pages, but every page it tries to scrape, it should move on from that page faster than it does, basically. It stays on the page a bit too long before it tries another one, and it wastes iterations. So you can see that here, all the different pages where we failed to retrieve some context from. You can see a lot of this stuff is repeated. So, we're repeating, going back to kayak, and then we're going between kayak and Monondo. Interestingly enough, we weren't able to scrape Skyscanner, and we've been able to do that in the past. So that's a weird one. I'm not sure why that happened. But anyway, it should have been able to correct itself. And the other interesting thing here is, as the agent started to go through those iterations, I noticed the integration agent started to get confused. So some of the prompts started leaking into the generated output. So look, take these into account when generating your response. Here are all your previous responses. So this is part of the prompt, and it's actually just verbatim outputted the previous responses into the generated response, which it shouldn't do. So that's not something I've observed with any other model I've tested. That seems to be something that 5.3 is doing. And I noticed it does it more as the iterations go through, because obviously that context is growing with every previous response. So it's probably confusing the model. And yeah, we weren't able to answer that question. You can see we're repeating the same things, trying the same websites, and having no luck until eventually it actually crashes out. So that is a fail. That's a fail for question 5. Question 6 was the multi-up question. How many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So straight away, it says population of Germans in Aruba, which is not what we want. And, that's going to lead us down a rabbit hole already. You can kind of see that. And you can see the integration agent is getting confused here with the feedback stuff. Again, it's putting the feedback into the response in a way that doesn't really make sense. And yeah, we're in this kind of loop of finding the German population in Aruba. So that's already going to be incorrect. I know that. And, we continue in that loop for some time. It doesn't actually manage to break out of that. It just gets more and more confused as we go down until we get to the final answer. So until we run out of iterations. And this does take a while before we get down to the bottom. We're almost there, I believe. Yeah, so we get down to the bottom here and we don't deliver a response. So you can see even the quality assurance agent says the response is false here. It's not comprehensive and relevant to the query. And yeah, we started off on a bad foot. We started off by looking at how many Germans are in Aruba, which isn't what we want. Fine. So that is a fail for question 6. Lastly, question 7. So this was rather interesting. I think we got the furthest on question 7 than we did with any other model, funny enough. So question 7, if you remember, is what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? So find the team that finished second in the 2023-2024 Premier League season. Yes, that makes sense. Locate the city where this team played its last match. Yes, identify the largest city north. Yes, this all sounds like a good plan. Logical, makes sense. That's what we want to do. And we've got the most important search here, search for the current weather forecast. So that's where we're going wrong here. That most important search shouldn't be the current weather forecast in the largest city north, city where the team that finished second in the 2023 Premier League season played its match. That doesn't make sense as a search. It's not going to return anything useful. Actually, what we wanted to do was start from the top and actually search those individual items. And this is a failure in the reasoning for the large language model too. And obviously the integration agents come back with something. So it actually says, based on the research, Arsenal finished second in the 2023-2024 Premier League season, which is correct. And that's not going to be in the model weight. It's not going to be in the training data. So I know that it must have pulled that from a source. It's not going to have made that up. Their last match was against Everton at the Emirates Stadium in London. That's also correct. That is also correct. So somehow, by some fluke, it's gotten to that answer. The largest city north of London is Edinburgh, Scotland, which is completely incorrect. The largest city north of London is Birmingham, and that's the largest by population. So that's not correct. That's not correct. That's not what I would expect to return. And then we've returned kind of a bunch of nonsense around the sources. So it's mentioning things like team news and all that. That's just a bunch of nonsense there. And then we continue on in that same way. So it's kind of gotten back into this weird feedback loop. And we continue on until we get to the end and we crash out. So that's a fail. Again, so you can see, testing the 5.3 medium model, there's definitely a lot of hype around this model right now. And you can see why the 128K context, and it's meant to be a small and powerful model. But you can see that there is a big difference in performance between that model and the Llama 3 70 billion model. Granted, I think the 5.3 medium model has a lot less parameters. I'm just going to double check for you how many parameters that model has. So if we look on Hugging Face, we can actually check it out. So yeah, it's a 14 billion parameter model compared to a 70 billion parameter model. So probably no surprises that it doesn't really match up to the performance. Anyhow, let's calibrate it on the matrix, and I'll do that next. I'll tally up the points and you can see where it lands on the matrix. All right, let's go over the points tally for the 5.3 medium model. So the first question was a pass, so we have 1 point there. Question 2 was a fail, so there's 0 points allocated for question 2. Question 3 also failed. Question 4 passed, so we get 4 points allocated for question 4, and that is a total of 5 points. And then we failed the remainder of the questions, so 5, 6, and 7 were fails. So we have a total of 5 points for the 5.3 medium model, which puts us between tier D and E for 5 points. So that's I guess that's kind of expected when you look at the landscape of the other models we test. It tested above the Llama 3 8 billion Instruct, and that's the GGUF version that's running locally, but below GPT 3.5 Turbo, which is, again, what you would expect, and certainly below the larger Llama 3 models and nowhere near Perplexity. I know I mentioned at the start of this video that this would be the third and final video, and I mentioned a bunch of models that we would be testing, but it turns out that it's taken a little longer than I anticipated to actually get through the models we've already tested. So I will be making a part 2 to this video where I will test some of the models that we didn't get a chance to test today in this video. In the next video, we're going to be testing CodeStraw 22B. So it'll be interesting to get a view on how the coding models work with these agent workflows, and if it is true that because they are able to follow logic better in some ways because they're trained on code, maybe those benefits can seep into agent workflows. We'll be testing GPT-4o. And instead of testing the Mixtral 8 times 22 billion model, which I already tried but couldn't afford to test for this video, I'll be testing its smaller brother, which is the 8 times 7 billion Instruct model from Mixtral. The models that are going to fall off the list are the 5.3 small Instruct model. We already tested the medium, so there's perhaps no need to go ahead with testing the small model. And Mistral 7B Instruct will also fall off the list since we'll be testing Mixtral instead. So Mistral 7B Instruct will fall off the list. If you enjoyed this video, give us a thumbs up, put your opinions down in the comment section, and stay tuned for my next video where I'll be testing those final models that I mentioned earlier. Looking forward to it, and I'll see you in the next video.